Assalamu alaikum, my dear students. How are you all? I think you are all with the grace of Almighty Allah. Welcome to NIEVS Home School. I am Muhammad Yamin Apu, an assistant teacher of mathematics, National Ideal English Version School, morning shift. My dear students, I am going to take a mathematics class for the student of class 7. Our today's topic today is chapter 9, theorem 4. That means from chapter 9 we will discuss only theorem 4. Your lecture number is 24 for the half yearly examination and your homework number is 16. Okay. And your homework is in chapter 9 theorem 4. That means the similar is your homework today. Now my students, let's start. Okay, the theorem 4 is, I have written down here, theorem 4 is the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, this is our theorem. So first of all we should write down the general enunciation. After that we should write down the particular enunciation. Then we should prove it. In before the proof, if we need the construction, we write down the construction also. Okay, so the solution here, first of all we will write down the general enunciation. Okay, general enunciation. General enunciation is nothing but about the question. Okay, we will write down, we need to prove that the sum of the length of the any two sides of a triangle is greater than the length of the third side. Okay, we will write down this as general enunciation. We need to prove that, we need to prove that, we need to prove that the sum of the length, the sum of the length, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, by the theorem it is clear that if there is a triangle, look at the triangle at first. Suppose this is a triangle, this is our triangle. Suppose this is our triangle, it's ABC. Okay, suppose this is A, okay, this is B and this is C. In this is a triangle ABC. Okay, and any two sides sum. Suppose BC is the biggest side, then the other two sides, that means AB plus AC, that's equal to, sorry, that is greater than the side BC. We need to prove that one. Okay, that means any two sides sum is greater than the third side. Okay, we need to prove this one. So write down the particular enunciation. Okay, after that you should write down particular enunciation. Particular enunciation. Particular enunciation is, we will assume or suppose BC is the greatest side. BC is the greatest side of triangle ABC. We suppose that what? BC is the greatest side of this triangle ABC. Now it is required to prove that, what is required to prove that? It is required to prove that AB plus AC, that is greater than BC. Okay, AB plus AC, this means this is the two sides sum of a triangle is greater than the third side is BC. Though BC is the greatest side, but if we add two other side of the triangle, then this sum will be greater than that bigger side. Okay, now we will prove this. Before this proof, we need to construct something. Okay, first of all look at the construction. In this figure we will extend the BA line, up to D, such that AD, that's equal to AC. Okay, that means these two sides will be equal. And my dear students, we will add this D and C point. Okay, this is our construction. So write down the construction. The construction is easy. The construction will be what? The construction will be, we will extend the BA line up to D. So write down extend BA up to D, and join the points C and D. Okay, extend the BA line up to D and we will join the point C and D. Okay, now my dear students, from this figure we will prove that this angle is equal to this angle. Okay, that means look at the figure, this angle D is equal to this angle C. That means the angle ACD equal to the angle ADC. How? We know that in an isosceles triangle the base angles are similar. That means base angles are equal. Okay, and we know this one from this figure, these two sides is equal to each other. So this triangle is an isosceles triangle. Okay, now the proof. Okay, we are going to prove this theorem. Before this important proof, we will prove this one. Okay, these two angles will be equal to each other. For this we should write down in triangle ADC, in triangle ADC, AD that's equal to AC. From the construction it's clear there. Okay, extend BC up to D. Okay, oh sorry, I have to write down this one also in the construction. My dear students, we have to write down this one. Extend BA up to D such that AD that's equal to AC. Okay, and join the point C and D. Okay, now we can write down in the triangle ADC the side AD equal to AC. So it's an isosceles triangle. Okay, and we know that in an isosceles triangle, the base angles are equal. The base angles are equal, and the base angles are what? These two angles. So we can write down, so the angle ADC that's equal to the angle ACD. From the figure it's clear. Okay, the angle ADC that's equal to the angle ACD, because this is the base of the isosceles triangle and the side, these two are equal. So it's an isosceles triangle, and we know that the base two angle will be equal to each other. I have write down this one. Okay, after that, my dear students, look, ADC angle means the angle BDC. So you should put it this one. Okay, the angle ADC equal to how much? Equal to BDC, nothing else. That's equal to the angle ACD. But look at the figure again. The angle ACD is nothing but the part of the angle BCD. From the figure it's clear that the angle ACD is a part of angle BCD. Okay, so write it down from the figure. The angle ACD is a part of angle BCD. Therefore we can write down angle BCD is greater than the angle ACD. We can write down the angle BCD is greater than the angle ACD, because this ACD angle is only a part of the angle BCD. So the angle BCD is greater than the angle ACD. Okay, now from this inequality we can put in the place of ACD angle, we can put the angle BCD, because ACD and BCD are equal to each other. Okay, so we can write down, therefore we can write down our BCD angle that is greater than the angle BDC. Okay, now come on the figure again. In the figure, and from this inequality we have got what? We have got the angle BCD, that means this total angle is greater than the angle BDC. These angles is smaller and this angle is greater, and we know that the bigger angles opposite side, is bigger than the opposite side of the smallest angle. So we can write down, therefore the side of opposite side of this angle is BD. Okay, so BD is greater than the opposite side of this angle is BC. So we can write down BC. We have get here. How we can get this? BD is greater than BC because the opposite side of the greatest angle is greater. Okay, we can write down the note, the opposite side of the greatest angle is greater. Okay, this is our note. So in the figure, from the figure we can get that the side BD is greater than the side BC. But my dear student, BD equal to what? BD equal to AB plus AD. Now BD, that's equal to what? That's equal to AB plus AD. And we know that BD, we know that AD equal to what? AD equal to what? AD equal to AC. From the figure, from the construction, we know that AD equal to AC. We can put it down. In the place of AD, we can put AC. In the place of AD, we can put AC. So we get here what? We get BD, that's equal to AB plus AC. So put this value in this inequality, we will get what? We will get, therefore we have in the place of BD we can put AB plus AC. So AB plus AC, that is greater than BC. Okay, so this is our required proof, my dear student. This is our required solution. It's AB plus AC is greater than BC. It was needed to prove, and I have proved this one already. It's AB plus AC greater than BC, and you can write down after this one proved. I hope, my dear student, you have understood how to prove this one. Okay, and you must do your HW number 16, because your HW number 16 is theorem 4, okay, in chapter 9. This one I have already done in the board, and you need to solve in your HW copy, and you should mention the HW number 16 in your HW copy. Okay, you can submit the HW on every Saturday from 9 AM to 3 PM. See you again inshallah. Till then, my dear students, Allah Hafiz.